Neutrinos, one of the smallest particles that make up the matter in this world, are known as ghost particles. Each second, 100 million neutrinos pass through the human body without us even being able to sense them. But these seemingly insignificant neutrinos are in fact an important lens through which to explore the mysteries of the universe. A decade ago, research in China on neutrinos had only just begun. 10 years on, in the Greater Bay Area, the origins of the universe as we know it are being pieced together from 700 meters below the ground.
Located in the town of Kaiping, Jiangmen City, there's a group of yellow towers that act as a connection through which we can come into contact with the past. But 36 kilometers away and 700 meters under the ground is JUNO, where people are building connections with the stars and the future of the mankind.
I will invite guests from Hong Kong to join me to adventure in the JUNO.
We now enter JUNO in a very special way. You ready?
Yes.
JUNO, a laboratory designed to capture neutrinos and study the makeup of mass through them, is under construction 700 meters deep below the junction of Jinji Town and Shishui Town in Kaiping City of Jiangmen.
Welcome to JUNO.
Nice to meet you, Dr. Meng.
Welcome.
Dr. Meng, can you give us a brief introduction about the crystal ball? Actually, I know it's a central detector.
Yeah, sure. So here is our experimental hall, and you can see here is our water pool. The height is 44 meters. In the center of this water pool is the heart of our detectors. It's so-called a giant crystal ball we call acrylic sphere.
The central detector is made up of stainless steel mesh with a diameter of 41 meters, 20,000 tons of liquid scintillators, and photomultiplier tubes.
So this is our photo sensor, and it's like a human eyes to look at the light. This is sensors to look the light produced by the neutrinos. And this 20-inch photomultiplier tubes is customized for this experiment.
The 20-inch photomultiplier was once produced by a non-Chinese company with a monopoly over the sector, and the price was very high. In 2020, China was able to acquire the production method.
So here is the entry of the bottom of the water pool, and we can go inside from here. And this is the air shower room, can help us to remove the dust from us and reduce the thick signal in the detector. So let's go inside and shower.
I'm spotless. Dr. Meng, what is the process through which neutrinos are captured?
Okay, let me show you. And for our detector, we capture the neutrino from the reactor in the Taishan and the Yangjiang nuclear power plants. And when the neutrino fly to us, and it hit our target, the liquid scintillator, and produce a light. And those lights can be captured by the photo sensors. And you can take a look at these detectors, and the photomultiplier tubes will install on this stainless steel structure. And it's looking inside of the center of the detector and can be captured the neutrino signals. The neutrino mass ordering is very basic and one of the most important questions for neutrino physics. And our detector is not only determine this, but also can detect the neutrino properties, which is describe the neutrino oscillation phenomenon.
Dr. Meng, I got a question from my student. His name is Kong-Macao from grade 10. He's asking what is the real purpose of neutrino in our daily life.
Neutrino is one of the basic particles in our universe. Better understand the neutrino property can help us to understand the universe better and where we are coming and where we are going.
To get capture neutrinos, an environment free from interference from cosmic rays is needed. So the deeper underground you go, the better. That's why JUNO is built 700 meters under the ground.
As a result, the Jiangmen Neutrino Laboratory carved out the largest underground cave in China, but this also brought on great challenges, because the tunneling and excavation of the hole was met with groundwater.
那么呢，因为现在我们的地下水位啊，大约在我们大厅顶上50米左右。什么意思呢？就是说，这就意味着我们现在这个地下大厅，包括廊道，都是在地下水位以下。那么呢，你知道我们的实验大厅加上水池呢，整个这个高度将近70米，高变相地下洞室呢，它的稳定性就非常至关重要。你看，这个位置呢，就是非常典型的一个地下的工况，这个就是我们当初基建开挖的时候碰到的困难，就是地下水非常丰富。为什么这地方水非常丰富？就是这个有一个断层。穿过了我们实验大厅，这对我们地下工程的影响，这2个因素对我们工程影响非常大。那么呢，后来就不得不采取加上特殊的工艺了，就是碳水注浆。那么为了控制这个水量对开挖的影响嘛，那么呢，我每往前开挖一段，都要事先把前面那一段的周边用水泥浆给它封堵住，这样呢，减少那个地下水那个影响，这样呢才能往前开挖，就这么交替的往前。这样呢，就为什么工期达到了7年，就是因为了控制地下水。我们现在呢就处在那个地下液散大厅，捕捉中微子的主要的物质，我们叫做液体闪烁体，它的纯净度达到最理想的纯净度，才能用于我们那个江门中微子实验。现在呢，地下呢这一对儿有不锈钢罐，叫做蒸汽玻璃重化系统。那么呢，这套系统呢，就是由意大利贡献的。那么地面呢，还有一套系统呢，也是由意大利贡献的。那么这4套系统，另外2套系统呢，是由我们中方高能物理研究所研制。
I've been here, I don't remember if it was 2015 or 2016, at JUNO site, and there were only chickens around, no street, no building. Installation here is unique in the world. There will be no other JUNO-like experiment because it's very, very huge. This is the only occasion to build an experiment like that, and this occasion could be done only in China.
比如我们江门中微子实验是由18个国家和地区组成的，其中地区呢就包括我们中国的台湾地区。在建设阶段，各个国家都是根据你的财力、物力和人力，那么呢，你有钱出钱，有力出力，有物出物，来对这个实验的建设做出贡献。建设完了以后呢，它采集的数据就送到北京和意大利2个数据中心，成果是属于合作组，700多成员共享。
Over the past decade, South China's Guangdong province has made solid progress in building the Guangdong-Hong Kong-Macao Greater Bay Area into an internationalized hub of science, technology and innovation.
在2014年启动的时候呢，广东省政府就资助了我们1.5亿，来解决3通1平的问题。去年呢，听到了我们的基建呢还缺口3个亿，那么在今年年初呢，广东省政府又补贴了我们3个亿的资金，这样呢能确保我们这个江门中微子实验能进一步往下推进。类似于江门中微子实验这样的大科学工程的建设，我们的中国也能对人类文明，包括人类的那个科技做出我们的贡献。
Once all equipment is in place, the detector will be filled with only the purest of water to shield it from anything other than neutrinos. Top of the pool will be sealed with nitrogen gas and covered with an airtight lid, which will, toward the end of 2023, mark the official launch of the journey to the stars and toward the future of humankind from underground in Guangdong.